Hello everyone. Today we will start with Unit 5, reviewing Unit 5, 5.1, burning. When something burns, a chemical reaction is taking place. So, what's burning? It's chemical reaction. Chemical burning is a chemical reaction in which substance combines with oxygen. Now, if we want to give a definition for burning, the definition will be burning is a chemical reaction in which a substance combines with oxygen. Here, as you can see, if you look at this picture, this picture, it shows the process of burning. Okay, as you can see here, we have coal. This coal, it's burning. Okay, then another term we call it, which is combustion. Combustion is another term used for burning. Okay, so now what burning or combustion, both of them, they are the same. Both of them, they mean a chemical reaction in which a substance combines with oxygen. In any chemical reactions, we will have reactants and products. In this example, combustion, the reactants here, it's carbon with oxygen, and the products will be carbon dioxide. So here, these two, they represent the reactants. This one represent the product. Again, as we said in combustion or burning, it's any chemical reaction in which a substance reacts with oxygen. Okay, burn with oxygen. Now, when you, or here in combustion of coal, or when you burn coal, you will feel hot. So, what happened here? The chemical reaction here, it gives out energy. This chemical reaction, in this chemical reaction, the energy is given out, or the heat is giving out. So this kind of reactions, we call them exothermic reaction. Again, exothermic reaction, a chemical reaction in which energy is given out is called an exothermic reaction. Now, let's solve some questions. Question number 1, it says, what is needed for combustion to take place? Combustion to take place, it needs what? It needs oxygen. Oxygen. Question number 2, what is an exothermic reaction? Again, exothermic reaction is a chemical reaction in which energy is given out. The word exo, it means out. Okay, thermic, it means thermal or heat, and reaction. So in another words, we can say reaction that gives heat out. Okay, how can you tell that burning is an exothermic reaction? Simply because this, when you burn any substance, a heat energy will be given out. So this is an example of exothermic reactions. Here we have another examples of burning. For example, burning magnesium. Burning magnesium, we did this experiment many times in the lab. This is the magnesium. When you burn a magnesium ribbon, we will see a smoke, white smoke with a high temperature will fall. Okay, so this is also, it's a kind of burning. This process to take place, it needs oxygen. So magnesium plus oxygen equal to magnesium oxide. Okay, so here it's an example of exothermic reaction. Another kind of reactions, we call it oxidation reactions. What do you mean by oxidation reactions? From the word oxidation. Oxidation, it comes from oxygen. So Any chemical reaction that where substance combines with oxygen is known as oxidation reaction. So here we have magnesium, it combined with oxygen. So this kind of reaction, it's what? It's oxidation reaction. Again, what do you mean by oxidation reaction? It's any chemical reaction in which a substance combined with oxygen. Question number 4. What sort of reaction is rusting? What do you mean by rusting? Rusting is when iron react with oxygen, it will form rust. So what kind of reactions it's rusting? It's an example of oxidation reactions. Okay, so this will be the answer. Now, which compound is formed when copper react with oxygen? Okay. When copper react with oxygen, okay, it will form copper oxide. This copper oxide, okay. Next question. When magnesium burns in air, what type of energy is the chemical energy changed to? Here what do we have? We have magnesium burning. Burning, it means converting of energy. Here, what kind of energy? It's chemical energy. This chemical energy will be converted into heat and light energy. Again, a summary. An exothermic reaction is one in which heat energy is given out. Burning or combustion is an example of exothermic reaction. Why? Because it gives out energy, heat energy. Burning is a reaction in which substance combines with oxygen. Okay, students, here you should not confuse between the definitions of exothermic reaction, burning. Okay, so each one has its own definition. When a substance combines with oxygen, we say that oxidation has taken place. More exothermic reactions. Here just we have more examples of exothermic reactions. Here we have this example. Potassium. When potassium reacts with water, potassium hydroxide will form, plus a gas will be given out. This gas is hydrogen. So what will happen, or why it's example of exothermic reactions? Because heat energy is released. Here here shows the example of reaction. Again, what do we call this two? The first two, we call them reactants, and they form these two, we call them products. Endothermic process. Endothermic process here is opposite to the exothermic reaction. Endothermic process. Thermic, we said it means heat. Okay, this it means heat, and endo, it means in. Okay, so what do we have here? We have process of taking heat, okay, inside. Okay, now endothermic reaction, some chemical reactions take heat from their surrounding and store it as chemical energy. These are called endothermic reactions. So what do you mean by endothermic reactions here? The chemical reaction is that it takes the energy from the surrounding. Here we have an example of endothermic reaction, which is sodium hydrogen carbonate plus nitric acid equal to sodium citrate plus water plus carbon dioxide. Here it's like sherbet sweet. Okay, when this sweet, when you put it in your mouth, what will happen? You will feel your tongue or your mouth it's cold now. Why? What happened? Because this a endothermic reaction. Endothermic reaction it just happened. It took the heat energy from the surrounded and stored it in. Again, differences between exothermic and endothermic reaction. If you just follow the arrows here, it's showing that exothermic process. Okay, here what it's happening. See the heat it's giving out. The arrows it shows the heat. Okay, here in endothermic process it's opposite. The heat it's taking in. That was the most important things in Unit 5. Your homework, again, it's the questions, end of unit questions, solve the end of unit questions, and also review the revision book for the checkpoint. And have a good day.